Hello, this is Muhammad Usman, and today we are going to discuss the frequency distribution and graphs for continuous variable. Let's just start with a simple example. On your screen you can see a data of 30 wheat plants, the height of 30 wheat plants, and as you know, height is a continuous variable, and from this data today we will learn how to make this kind of table, the frequency distribution, and how to construct histograms. Remember, the frequency distribution of a continuous variable and histogram tells us about the distribution of data. Today we're going to learn how can we construct these two from a continuous variable. Well, first of all, we will see what is frequency distribution. It is a tabular arrangement of data, and we will denote frequencies with small f. What is class limit? Well, we will construct classes, and each class starts from a number and ends at a certain number. The starting number will be known as the lower class limit, and the ending number will be known as the upper class limit. Class marks or midpoints, well, it is simply the average of two class limits. Class interval. It is the difference between two successive upper limits or two successive lower limits. It is denoted by small h. Well, following are the steps which you need to follow in order to construct a frequency distribution. First of all, there are two types of formulas which we can use to assess the number of classes. Then you have to calculate the range of the data, and by dividing that range with the number of classes you will get the class interval. Decide whether to locate the class, and at the end you have to distribute your data into those appropriate classes. So these are the 5 steps which you need to follow in order to construct a frequency distribution of the continuous variable. This is the same data which I've already shown to you in the first slide. Well, in the first step we have to assess how many classes. So both formulas, they are giving us a value of around 6. Remember students, we need to round this number, so there may be 6 classes or 5 classes, so rounding up will give us the figure of 6 classes. Okay, the second step is to find the range of the data, the maximum observation minus the minimum observation, and you have to divide this range by number of classes in order to get the class interval. In this case it is 5. We will start our classes from 86 because the minimum value is 87, and that should fall in your first class. And now the last step is to distribute your data. So your classes will look like this. The first class will start from 86 and it ends at 90. 86 is the lower limit and 90 is the upper limit, and you can see all the classes on your screen. This column represents the class boundaries, and I will discuss in the next slide how to construct those class boundaries. Well, the third column is of tally mark in the counting, and after that you will get the frequencies. The frequency for the first class is 6. That shows that there are 6 plants having height between 86 centimeter to 90 centimeter and so on. Cumulative frequencies. Well, you have to add up the frequencies in order to get the cumulative frequencies. First cumulative frequency will be same as that of a frequency, and then later on you have to add the next class frequency to get the cumulative frequencies. Relative frequency, same as that it was in discrete or qualitative case. You have to divide the corresponding class frequency with the total frequency. And the for the percent frequency, you need to multiply each relative frequency with 100, and the sum of the percent frequency will always be equal to 100, and for the relative frequency the sum is 1. Cumulative percent frequency. You need to cumulate the percent frequencies here. Well, class boundaries. It is a continuity correction. Basically, you need to see the difference between the upper limit of the first class and the lower limit of the second class. That difference is 1 in this case, and that you will divide that 1 with 2, you will get 0.5. Now you need to add this 0.5 in all the upper class limits, and you need to subtract this number from all the lower class limits. This will make up of the class boundaries which we will use in histogram. In the next slide, you will see the histogram of the data. Well, on the x-axis, you will take class boundaries, and on y-axis, you will take frequencies. Well, I'm going to repeat again, your graph should be independent from your table. That is, your graph should be properly titled, as well as your x-axis and y-axis will show clearly that what you have taken on your x-axis and what you have taken on your y-axis. So this graph is showing you the distribution of the data, how the data values are distributed. That is the main purpose of the histogram. Well, from the histogram, you can make frequency polygons. It is quite simple. You need to take the midpoints on x-axis and frequencies on y-axis. And then you need to join those points with a straight line to get a frequency polygon. It also gives us an idea about the distribution of the data. And the last graph is the cumulative frequency polygon. We can also call it an OGAF. Well, you need to take the upper class boundaries on x-axis and cumulative frequencies on y-axis. It is an increasing function because cumulative frequencies, they increases with each class. Well, the last topic today we are going to discuss is stem and leaf display. Well, moving from frequency distribution to the stem and leaf display, let me talk about one or two things here which are really important. Well, stem and leaf display, we prefer to use this graph for small data sets, for relatively small data sets, and you will see it gives us an additional information as compared to frequency distribution or histograms. Frequency distribution and histogram will only give us information about the number of values falling in certain class. Whereas stem and leaf display will give one additional information. It will also tell us that what is that value. So we'll see it shortly. Small example of 13 values is on your screens, and you need to construct the stem and leaf display by taking 10 units as width and by taking 5 units as width. Well, starting from first part, you need to divide each value into two parts. One part is a leaf part and the other part is stem part. Just consider the rightmost digit as your leaf and the left one will serve as stem. You need to draw a vertical line on your paper, and you have to write stem on the left side and the leaves on right side. Well, same is the case with the taking 5 as unit. Just you need to divide that stem into two parts, 3 star and 3 dot. 3 star will take values from 0 to 4 and 3 dot will take values from 5 to 9. Well, this is another example. Suppose this is a data and you have to construct a stem and leaf display. So the most right digit will serve as your leaf and the preceding digits, they will serve as your stem. So possible stem in this case will start from 7, 8, 9, 10, 11, 12 and 13. This is giving you an information about the distribution of data and what are the values falling in which class. Like in the first row, we can read those values as 70, 75, 78 and 79, and we can also count that there are 4 values in this class. Thank you very much.